So here, the question is, a 40 kg girl wearing a high heel footwear balances on a single heel. So this is the weight of the person. If the diameter of the circular heel is 1.2 centimeter, okay. So we
Okay.
have seen the yield slippers like this, correct now?
Uh-huh.
Right?
Yeah.
Yeah. This is how the heel slippers will be. So here the diameter of the heel they given.
Yes,
This is
sir.
the diameter of the heel, that is 1.2 centimeter. Very, very small, correct now?
Yeah.
Calculate the pressure exerted by the heel on the horizontal floor. Okay. Observe here, this is a very sharp edge, we can say,
Yeah.
compared to the shoe length.
Yeah. Yeah.
Correct now? So how much pressure will be exerted on the floor?
Yeah.
So we know that P is equal to F by A, this formula. Generally, you can think that as the area decreases, see, if the diameter is very, very small, the area is also very small, correct? No?
Yes,
If
sir.
the area decreases, the pressure will be increases. So the greater pressure will be act on a floor,
Okay.
right?
Yeah.
Yeah. So I can solve this problem by using the formula F is equal to mg. So m is the mass of the girl, that is 40, into g is the acceleration due to gravity.
Yeah.
So it becomes 400 Newton.
Okay.
Now area is a pi r square, correct?
Yeah.
But r is nothing but d by 2 because the data is given in terms of the diameter. So it will be the d by 2 whole square.
Okay.
Now substitute in that, find out the area. Pi value is 3.14
Yeah.
and the d value, see diameter 1.2 centimeters are there.
Yeah.
So it is 1.2 into 10 power minus 2
Sure.
whole divided by the 2
Okay.
to the square. Okay.
Uh-huh.
So after solving this, see what do you get? Just check it. 1.2 square. 1.2 square divided by the, or 1.2 divided by 2. How much you get? Will you get 0.6? 0.6 into 10 power minus 2 whole square. So solve it. 3.14, 0.6 into 0.6.
0.36.
Yeah, into 3.14 you should do. So it become 1.1304 into 10 to the power minus 4 meters square.
Okay.
So this is the area of the heel, circular bottom heel. Correct now? This one, area of the heel it is at the bottom. Now I can find out the pressure very easily. The pressure P is equal to F by A. F, it is calculated here, 400 Newton whole divided by A value 1.1304 into 10 power minus 4.
Okay.
Yes, solve for this. You can take this 10 power minus 4 to numerator. It will become 10 power plus 4. And you just divide here 400 by 1.1304.
1.13.
This 400, you can write it as a 4 into 10 power 2. Okay.
Okay.
Then 4 divided by 1.1304. Yeah, I'm getting here 3.538
Yes, sir.
into, see here 10 power plus 4 into 10 power 2. Totally it become 10 power 6 Pascal.
Okay.
So it's a very greater pressure it is. Correct now, 10 power plus 6 Pascal.
Yeah.
So that much of pressure is acting on the floor because of the heel.
Okay.
As the weight of the person, as the weight of the girl increases, then more pressure will be acted on the floor.
Yes, sir.
again. So here is a building, has an overhead water tank connected to taps on each floor. Okay. Basically like apartment kind. Okay. It has a like many floors, right? So it is connected to every floor through the taps. The pressure of water at the ground floor is given. It is always greatest at the ground floor, as we know that. And on the third floor, the pressure is 98 into 10 power 3 Pascal. See, at the third floor, it is little less compared to the ground floor. Now, by using only these two data, we have to find what is the height of the third floor, not the height of the building. We have to find only height of the third floor. That's it. Okay. Yeah. So here at the third floor, okay, let us take, here is a building. So ground floor, first floor, second floor, third floor, fourth floor. Okay, there are many, let it be.
Yeah.
Now I am coming for the third floor here. This is the third one.
Okay.
Here at the bottom, what is the pressure? It is 98 into 10 power 3 Pascal. Correct now? And on the third floor, it is 196 into 10 power 3 Pascal.
Yeah.
Correct now?
Correct.
Now, what is the pressure difference? Observe that the pressure difference is equal to, so highest minus the lowest.
Yeah.
Correct? I think I have written ulta.
Yeah.
Yeah. Here it is. See here it is less. Here it is 98. Here it is 196 at the ground floor. No?
Yeah.
Yes. So the pressure difference is 196 into 10 power 3 minus the 98 into 10 power 3.
Okay.
Pascal. So if you subtract it, you will get 98 into 10 power 3 Pascal only. This is the pressure difference. So basically this pressure difference is nothing but what? Rho G H. This is what we proved in the last class, right?
Okay.
Rho G H. Rho is the density of the water. G is the acceleration due to gravity. And H is the height through which the water flows. Okay. Understood?
Yes. Understood.
Now height of the third floor from the ground. So that we are going to find. So now H becomes 98 into 10 power 3 whole divided by, send this rho and G to the denominator. 98 into 10 power 3 divided by, what is the rho value? It's the density of water, 10 power 3 only into 10. So your 10 power 3, 10 power 3 get cancelled. Okay.
Yeah.
So what will be the height? It comes 9.8 meters. So this is the height of the third floor. Okay.
Okay.
Yeah, that means compared to the ground level.
Yeah.
The ground level, the third floor height is
9.8 meters. Okay.
Okay. Small change it is. That's it. So G value anyhow 9.8 is given. You can take it. If they're not given, you can take it 10. Then here we get the 10 meter as an answer.
Okay, sir.
Of cross section of a wider tube is 800 centimeters square. Here is a wider tube. Okay, this area is 800 centimeters square.
Okay.
If a mass of 16 kg is placed on the piston, you can see the piston here.
Yeah, I can see.
So this is the piston. Over the piston, 16 kg mass is kept over there. Find the difference in the level of the water in the two tubes. Observe. Obviously, as you keep pushes the liquid at the one side, so other side the liquid level raises. Correct, no?
Yeah.
Yes. So this much of difference we get. So this is the height difference. See here, compared to this level, So here, this much amount of liquid in the second tube as raised up.
Okay.
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 Let's solve it here by one. Increase in pressure in the liquid. Increase in pressure in the liquid in wider tube. So usually pressure formula is what? F by A, force per unit area.
Yeah.
So that increase in pressure is basically depends on its density, acceleration due to gravity, and height. So that I can write it as a F by A. The pressure can be written as rho GH, right?
Okay.
So what is the H here? H is nothing but difference
Okay.
in the levels of water.
Okay.
Okay. So you should compare to the one tube to another level. Okay. So this is here the height H and this tube level is here. So the distance between them is H. And area value is how much? 800 centimeters square. It is given here. Area. So
Yeah.
just convert it into meter square first.
Yes, sir.
So that is 800 into 10
10
power minus 2 the whole square. Centi means 10 power minus 2. Since there is a square, 10 power minus 2 whole square.
Okay.
Okay. So that I can further write it as a 800 into 10 power minus 4. Or we can write it as a 8 into 10 power minus 2 meter square. Because this 800 can be written as 8 into 10 square.
Okay.
Plus 2 and minus 4 will become 10 power minus 2.
Okay.
And I need to find out this F. So calculate that also. F is equal to mg.
Yeah.
Right?
Yeah.
So now you can substitute there. F is equal to mg value.
16 by 10.
So m is how much? 16 kg. And g is 9.8.
9.
Yeah, 9.8 Newton.
Okay.
Now substitute here in this. So rho GH.
Oh, okay. Rho G.
Yeah, in this form is equal to F by A. F is 16 into 9.8.
9.8 by
By A. Area
8
is 8
into
into.
10 power 2.
Okay. Now I
Yeah.
should find out the H here.
Yeah.
Correct. Now find the difference in the level of the water in the two tubes. That itself is the H.
Yes, sir.
Right? Difference in the levels of water.
Okay.
Yeah. So keeping the H value here, 16 into 9.8 whole divided by 8 into 10 power minus 2 into, see this rho and g value goes to denominator. So the rho value become 1000. It is given. Correct now? Water density it is.
Yeah.
Water density, you can check in the previous problems here. 10 power 3 means 1000 kg per meter cube. Or you can write it as a 10 power 3. And g value again 9.8. So it will be cancelled. Now find out the H value. Your
Sir,
H
what
value
about that 8 into 10 power minus
8 into 10 power minus 2. Yeah,
2?
you can take it
Okay.
to,
Okay.
yeah, 8 2 side will be cancelled. Take it to numerator.
Uh-huh.
10 power plus 2 it becomes.
Okay.
And here 1000 is there. You can do it as a 10 power 3. Totally here 2 into 1 10 power minus 1 will be multiplied. 2 into 10 power minus 1 it become. So that will be 0.2 meter.
Okay.
So this is the H. Okay, what is a H? Difference in the level of the water in the two tubes. Problem. Next problem. A piece of cork of density 250 kg per meter cube floats on water of density. Water density is given with 10 into 10 power minus 6 meter cube. What it is? This is the volume. Okay. So this much of the part of the volume of a cork is floating above the water. Now we should find out mass of the cork. Understood? Understood there?
Yeah, understood.
Yeah. See, this is the water.
Yeah.
So here I am taking the cork. Just a minute. So this is the cork here.
Okay.
So here, only the small amount, okay, only the small amount of the cork, this one,
Yes.
how much it is the volume? 10 into 10 power minus 6 meter cube is floating above the water, correct? No, it is above the water. Yeah, we don't know what is the below the water, how much volume is, okay, sink. But let's take the total volume of the cork will be V. Okay, capital V you can select.
Okay.
Yeah, here according to the question, what they given. So the density of the cork is given. Let's write that. Density of the cork, 250 kg per meter cube. And density of water is there. It is 1000 kg per meter cube.
Yeah.
Now, volume of the cork above the water. Volume of the cork above the water. So that you can take it as just X. Okay, this is the X value.
Okay.
Correct now? 10 into 10 power minus 6 meter cube. Okay, let capital V be the total volume of the cork. Now fraction of the cork floating will be, means we are comparing out of the total volume, how much amount of the volume of a cork is floating.
Okay.
So fraction of volume of cork floating above water, that will be X divided by V. The total volume is V. Out of that total, only the X amount will be keep floating.
Yeah.
Right?
Yeah.
So now I can apply here the concept that Archimedes Principle. How much the mass of the body is sinked inside the water, that much of water get displaced. Correct now?
Yeah.
So mass of the body is equal to mass of the water displaced. Mass of the water displaced. Yeah, mass of the body means what? Mass of the cork.
Yeah.
Right?
Yeah.
And mass of the water displaced. So these two things. So first I'm writing this mass of the body. See, from the volume concept, the density is nothing but mass by volume.
Yeah.
So mass, I can write it as a density into volume.
Yeah.
Correct?
Yeah.
So I'm using this concept now. So mass I'm expressing in terms of the volume into density, density of the cork it is. Here water is going to displace, right?
Yeah.
So here the volume will be V minus X.
Okay.
See here the total volume I taken as a V.
Yeah.
But in that the part of the volume is above the surface of water, that is X.
Yeah.
Then what is the remaining part which is immersed? That is V minus X, correct?
Yeah.
Yeah, that V minus X into density of the water.
Okay.
So both will be equal now. Now, in the next step, I can write this as a, see, I'm taking this density terms to one side, the volume terms to one side. V minus X divided by V is equal to rho cork divided by rho water. So further on simplification, you can separate the denominator here like this.
Yeah.
The rho cork value is given 250 kg per meter cube. Density of water is given 1000. So this will be 254, it get cancelled, right? 1/4.
Yeah.
Here the term V and V will be cancelled. 1 minus X by V is equal to 1/4. Therefore, 1 minus 1/4 is equal to X by V. Just I am taking this 1/4 to here. I am sending the minus X by V to the right hand side. Therefore, X by V becomes, take the LCM, 4 minus 1, that is 3, 3/4. Therefore, volume, the total volume of the cork, that will become 4/3 into X. But we already know the X value. 4/3 into, how much is the X value here? 10 into 10 power minus 6.
Yeah.
10 into 10 power minus 6. So the total volume of the cork we found out now as a 1.33 into 10 power minus 5.
Okay.
Minus 6 plus 1, minus 5 meter cube.
Okay.
We found the total volume, but what the question is, we have to find the mass of the cork.
Okay.
Okay, so let's find out now. How to find out the mass of the cork. Yeah, so the mass of the cork is equal to density of the cork into its volume. Correct, no?
Yeah.
The total volume of the cork. This one, just now what we saw, this is the volume of the cork.
Yes.
Total volume of cork. Yeah. So rho cork will be 250 into volume. We found out that 1.33 into 10 power minus 5. So the mass of the cork, just multiply them. 1.33 into 250. So I'm getting 332.5 into 10 power minus 5 kg.
Okay.
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 Yeah. This is the mass of the cork. Check it once again. The density of the cork is given. Density of water is given. volume of the cork above the water level. That is also given 10 into 10 power minus 6 meter cube. Let us consider the capital V be the total volume of the cork.
Okay.
Then the remaining part, whichever is immersed, is V minus X.
Okay.
Then fraction of the volume of the cork floating above the water will be X by V.
Okay.
So according to the Archimedes principle here, mass of the body is equal to mass of the water displaced. I am expressing the mass in terms of the density and volume on both the side. And I substituted all the values here. First, I found the volume, total volume of the cork. After that, I found mass of the cork.